Thanks for joining us tonight. We're at the Partnership for Innovation building here in Bethlehem, Pennsylvania, and we're going to be talking about a little bit of an introduction to nerves. I'm going to bring up a couple slides here, and we're going to talk about that. I do have somebody, Chuck came down, was able to join us, so at least it's not just me talking to a computer in this room for a while. Hopefully we can have some good feedback from you guys as well. There is, if you're in the Google Hangouts app, there is a group chat. Otherwise, you can contact us with some messages, I guess, easily on the Slack channel. So if you're part of the Elixir Lang Slack channel, I'm sorry, if you're on Elixir Lang Slack community, you should be able to join the Nerves channel, and inside of the Nerves channel, you'll be able to talk to me, I guess, ask some questions. I have that application open right now, so throughout the thing, I'll collect some of the questions as we go, and if there's ones that pop up that are pretty important at the time, I'll just jump into it then. Otherwise, at the end of this, we'll do a little brief recap of everything that that we talked about throughout the presentation of this. So let's get started, and let me just share my screen here. Do a little infinite window, all right? And here we go. So I have a few slides here. I'm also going to do some live coding presentations. But today we're going to talk about introduction to nerves and what it means for embedded Elixir. So embedded Elixir, first off, here's some information about myself. My name is Justin Schneck. I work for a company called LiveHelp Now, and we do online chat software. We are heavy proponents of Elixir, and we're starting to move a lot of our systems over to that. You can also find me on Twitter and GitHub at Mobile Overlord, but you can also find me on IRC and Slack. I go by Jay Schneck there, or some other places you might find me as Justin Schneck. It's a little confusing, but you can pretty much track me down if you need to. So some of the topics that I want to cover tonight are a general overview of what embedded Elixir is and what it means, what nerves is, and how that might make embedded Linux development a little bit easier. We can go into some examples where I can show you how some of this code runs and builds for the first time on Raspberry Pi, BeagleBone Black, things like that. I want to show a few pieces of how nerves is being used in production. And we can talk briefly about some community projects that have been going on through the Slack channel recently, I've seen. So what do we have first? Well, first, the question that we have is, well, what is embedded Linux? Some people aren't really familiar with this kind of world when it comes to small little devices. So embedded Linux really is typically just well, Linux is an operating system, and these devices have higher processing power, CPUs, and memory. It's basically your last decade's machine today. But it can fit in your pocket if you wanted to, and runs on really low power. So these devices are really nice because they give us the ability of having a higher processing power and more resources available for us to be able to do cool things like run Elixir or run higher level code. They also give us access to pins that we can interact with things around us in our world. We can build cool things like we can build tiny little web servers that can control garage door openers and security systems, all this, and really. So Linux for these embedded devices usually comes in a series of flavors. One of the most popular ones is Raspbian, and that's based off of Debian, which Ubuntu you can also load on some of these devices, which is also based off of Debian. And then the other side of the house, there's a couple projects that have been able to get Fedora running on it. Those images don't seem to be as stable, really. When playing around with Raspberry Pi, if you're a beginner, you can stick to the Raspbian builds. Those are pretty easy to be able to get on there. Usually there's a great deal of instructions available on the sites like the Raspberry Pi sites. Or if you're using BeagleBone, you can also go to their sites. They'll teach you how to be able to just download a canned image if you wanted to run full-on Linux on one of these devices. So what are some of the problems that we experience when it comes to embedded Linux and that we're trying to address? Well, for one, size is a big problem. And so we don't want this giant OS on our devices because we just need to blink a light or push a button or open a garage door. We don't need this entire operating system because, well, another reason, the boot time of it is quite large. I mean, it'll take a decent amount of time to be able to fully boot into Debian, especially on hardware that has some slower processing speeds and lower memory than your quad-core, 8-core, 16-core machines of today. And then that's another reason is the overhead. Well, it takes a while. And one of the other hardest problems is providing system updates or software updates. How do you ensure that you can send firmware packages down to these devices and that people will be able to update the firmware? And if anything goes wrong, well, how can you roll back? And with a full-on Linux installation, those aren't really those packages and those measures that you use to be able to perform software updates are large and cumbersome methods. So how do we attack these problems? Well, we use it with nerves. And that's where we've come up with this concept of nerves. So what is nerves? Well, all in all, nerves is a platform for building embedded devices. And this platform has a couple different components to it. One of the components is frameworks. So if you need to be able to interact with different parts of the system, like LEDs or communication buses like SPI or Ethernet, Wi-Fi, stuff like that, well, we're offering a suite of frameworks that will allow you to be able to, from inside of Elixir, access that functionality of the processor or the architecture itself. In addition, it's a collection of systems, and we can get into a little bit more about what a system is later. But ultimately, a system is the smaller version of the underlying Linux platform that's targeted specifically for, in this case, you can see we're listing BeagleBone Black or BeagleBone Blacks, Raspberry Pis, Raspberry Pi 2s, Galileos, things like that. And it's also, we have a suite of tools to be able to help you build these things a little bit faster. One of those tools is Bake. We also have Cell, which allows you to be able to discover things on the network, your Nerves nodes, like plugged-in Raspberry Pis from your laptop. And then Nerves itself, which is a helper application library that gets put into your Elixir applications that does most of the grunt work for getting these images to be able to be burned and put onto Raspberry Pis and SD cards. So here's what it takes. We talked about some of the pieces, these components, these systems and tools. Well, what does the big picture look like? Of this slide here, really all that you care about is your application. So your application is going to use some underlying componentry. Nerves provides these things called tool chains and systems, as we just spoke about the systems. Well, the tool chain is a suite of cross-compilers. Like if you need to compile C code, which a lot of times we do for ports and NIFs in Elixir and Erlang to communicate with the outside world. It's also a means of being able to connect you with all the cross-compiled binaries, like a cross-compiled version of Erlang, a cross-compiled version of Elixir, those kind of items. So what we do is we take your application code and using a tool chain and the system, we turn that into firmware. So a firmware is basically your application running on a system that you can then burn onto an SD card. So the important thing here is that, like I said before, all you need to care about is the application and then what you want to write, what you want to do with Nerves. And we'll take care of the rest underneath. That's part of what the Nerves platform supplies. So what does the SD card look like and why is it important to solve those problems? Well, essentially, when we burn the file systems onto an SD card, it's not just one file system. We actually partition out the SD card so that we have some upfront items like the master boot record, the bootloaders, to be able to boot the Linux kernel, boot into Erlang, and then the root file system, which contains a lightweight suite of tools and also your application. And in addition, we have an application data partition. I'm skipping over root file system B for a second, just to talk about the application data partition. Well, this is a read-write section of memory that we're using, that we're allowing people to be able to store data and retrieve data back again from that. And this is important because your root file system we're leaving as read-only. And that's because these devices, these Raspberry Pis, BeagleBone Blacks, these small embedded devices, I mean, really, you can just think about it as being able to have the plug pulled on them at any minute, and the power will go out. And I mean, if your computer would do that, that's bad news. You know, you'll have corruption. Eventually, your disk's going to die. Something's going to happen. So in this case, we leave the root file system as read-only because if you're in the middle of a write operation, you pull the plug, it's bad news. But if it's read-only, there's never a situation where you're going to be in the middle of a write on that partition, meaning that your application should, in theory, always be available and intact. Now, the reason we do two of these is for a alternating firmware update strategy. So you'll be able to write new firmware to another root, to let's say the root file system B. So if you're on A, you can upgrade the firmware on file system B, and then your device reboots. Well, it just switches the master boot record to point to file system B, and then now you're fully upgraded. And if something goes wrong, well, we can just we still have the last known working copy on the last root file system. We'll just bounce back to that. Some different strategies here that a lot of people take is because you can't really write to the root file system partition. You have to write to the application data partition. Usually, what we say that you can do is you can ship your application with like a known good state, and if you need to be able to, let's say, store SQLite data or some sort of like small databasing on the read-write partition, you can do that and then check before you load it to see if there's corruption, and if there is, then just reflash it, like lay down the good known state of it, and then you're gonna have to unfortunately start over, but at least you'll be able to continue along the way. So what does this look like on all in all? Well, the reason that we did this is because at first you can see this is Nerves versus Raspbian. So if we boot up a node that's running Nerves, well, it's going to take about 3 to 6 seconds to boot to your application. Whereas if you boot up a full Linux like Raspbian, it could take anywhere from like 30 to 60 seconds. All in all, the size, there's a big difference. You can see a Nerves image, which contains the entire firmware. That's the Linux operating system, that's your application, that's Erlang, that's Elixir, all the libraries. That's 13 to 18 megabytes in size. Whereas on Raspbian, it takes, it's 350, 500 megabytes. It's large, it's an entire OS. The update strategy, well, you can just lay down an entire new image with Nerves. And with the Raspbian, well, you might just have to deal with updating your application, but what if your application requires additional packages, and then there's an entire thing that you have to wrap around that, and could become a nightmare. And then the root partition, well, we keep things small and compact and tidy. We're only going to take up a small foot space that we can put out there versus 1 to 2 gigabytes of a large chunk in size. We have fallback strategies. It's unpluggable. I mean, the list could really go on, but alone, the important part here is that, working with Nerves, it's going to boot really quickly. It's going to give you strategies for producing projects that can turn into actual products. So as part of the tools that we provide, there's a tool that we also have created called Bakeware. And Bakeware is a separate component of away from Nerves, just because we think of it as a helper for Nerves, and that in reality, Nerves is a lot of these scripts that are underneath behind the scenes. And what Bakeware does is it gives you a higher level to those scripts to be able to easily use those systems and tool chains on other devices or on other host architectures, or like Mac OS, for example. Because the system is Linux, you have to use one of our our system compiler, Nerve System BR, which uses buildroot to compile a Linux, the Linux system itself. And doing that is not just an easy, willy-nilly task. I mean, it takes quite a long time to be able to build these things, depending on the power of your machine. And iteration over time, you could see, is going to be long. You know, every time you would need to make a change underneath, well, you could have to recompile Linux. Now, we kind of got people past this by saying, okay, well, we're going to package up a set of minimal images that we believe are going to give people the ability of all they need to be able to create Nerves applications that they can load into firmware. So we supply these for BeagleBone Black, Raspberry Pi. That's Raspberry Pi A+, B+, Raspberry Pi 2, also Raspberry Pi Zero, and Intel Galileo for x86. And so that you don't have to be able to go through the long-running tasks of having to compile Linux, having to build a toolchain. All of this is sort of cached and available to you using Bake. In addition, we also give you a faster environment setup so that everything, like I said, is all done, taken care of you behind the scenes. It's the magic. And we also give you the ability of doing multi-target, which allows you to be able to deploy for, let's say, a BeagleBone Black or a Raspberry Pi, all those different platforms with the same application code, switching between them. So Bakeware installation, it's important that you go and check this out. If you want to be able to play around with Nerves, it makes it real easy. You can go to bakeware.io, and that's going to show you some information on just run the script. Everything's going to be great. You can pick it apart. I urge you to do so if you would like to. Greg Mefford on the Slack channel has also contributed towards this as well. I believe there's an open ticket or an open issue that we have on our GitHub page for supporting more operating systems, like getting it running on Linux. And we're also trying to be able to provide Windows support as well, but that's quite a challenge that you know, there's some other things that we have to work with as well for that. So all right, and that brings us to, well, how do we do some of this? Because sitting here looking at slides is fun, but it's nothing without actually doing some work to be able to get things running. So what we like to call in Nerves the hello world is Blinky, and it's really funny because there's nothing quite like flashing a light. So we're going to try to do some demos here, and bear with me. Let's try to do some fun live coding in this case. So, all right, everybody sees me again. Hello. Let's get you. All right. So, here we go. I've got some applications open here. Let's just start with the Blinky one. So what we're going to do is I'm not going to, we're going to actually create this from scratch. We'll pull some components in from the other one, but I'll show you what it takes to be able to go from start to finish, let's say, to get a Nerves application up and running. And that's going to be from mix all the way through to burning it, and then we'll see it blink here as well. So the first thing I'm going to do is I'm going to create a new project. Let me just make my type a little bit bigger here. Let's do make a project, and we'll call it Blinky. All right. And here we go, brand new, fresh project. So the first thing towards creating a Nerves application is you're going to require a few things out of the gate. You're going to require some dependencies. one of which that's important is the nerves dependency. And right now you can get that on hex, and I believe it's 0.2.0. We're going to need that, and we'll add it to our applications list here. All right. And in addition, while we want to use bakeware here, we're going to need a file called a bake file. So I'm just going to add a new file to this, and we're going to call it bake file. And I believe on our website there is an example of this bake file, but I'm just going to jump over here and steal it quick. There we go. And the bake file, what this does is it allows us to be able to declare multiple targets. So right now we're saying that we have a target called RPI, which is a Raspberry Pi, and we want anything that's after 0.1. So we also have another target that we're saying we have Raspberry Pi 2 and BeagleBone Black. Well, these are pretty much the most popular boards that are out there, so we're going to just stick with these right now. But actually what I'm going to do is I'm going to mainly focus my stuff on the Raspberry Pi 2 because I have one of those in front of me here. So in this bake file here, we're declaring these recipes. Again, these are available. These recipes are made available. These are recipes for systems, and these include all of the sort of underlying things that you require to be able to get this running. It's the magic, the secret sauce. And so now that we have this bake file declared, let's pull in one of our systems here. So you know, you can call it the bake. You can you're going to use bake system get, and you can pass it a target. So I'm going to say Raspberry Pi 2. What did I type wrong? Oh, right. Yeah. It helps when you save these files. There you go. All right. So it looks like I already have this system here. I'm using the release candidate one, but you know, we can use this one for Blinky. Let's give it a shot. So now that I have a system, I need to make sure that I have the toolchain for this system, and that's a call basically to make toolchain get. All right, and well, let's just see here that my toolchain for that system is up to date. This is an online operation, so if you didn't have these, it would download them. I already have them cached on my machine, though. And you can share them between projects, so it's going to not take up too much space on your machine. So now that we have a system, we have a toolchain, we're ready to pretty much bake some firmware. Well, right now, this application is not really going to do much. It's basically going to boot just to nothingness, all right? And there's not really much here as far as configuration and application, but ultimately we should be able to make firmware. So let's try that out. That's called a bake firmware. Now you notice the redundancy here. We continue to have to pass this target. Well, maybe we offer some levels of convenience to be able to prevent you from having to pass this target all the time. Let's say you only have a Raspberry Pi 2. Well, the easiest way to set this, you can actually, we expose some functionality that allow you to be able to set this stuff, like bake global set default target. All right, we can set this to Raspberry Pi 2. Now at this point, I can just say bake firmware, and you'll see that it chooses my global default target for Raspberry Pi 2. At this point, bake firmware is going to take over, and it's going to do everything that we need. It's going to download the dependencies for the app, or I'm sorry, it's going to compile the dependencies for the application. It's going to create an OTP release. It's going to include all of the libraries for Erlang that are cross-compiled for us. And at the end, it's going to produce an FW file, which is a firmware file that you use a tool called FWUp for. But we don't have to use that either. We can actually handle that right through Bake as well. So now if we look at our directory structure here, we'll see that we have an images folder. And if we look in there, we have our Blinky for our Raspberry Pi 2. So one of the things I mentioned about the Bake file, especially, is that Bake offers the ability of doing multi-target. So we can build this for these other devices, Raspberry Pi, BeagleBone Black. To illustrate that, I mean, right now I have my global default target set, but if I go back and I say, okay, make sure I have my system for the BeagleBone Black, it'll get that. Make sure I have it for the Raspberry Pi, it'll go get that. You can do the same thing then for, oops, looks like it has to download this one. You can do the same thing then for the tool chains as well, and then switch between them pretty conveniently. I'm going to kill this one for now. And so I can right from here I can say bake firmware, and I'll say I want to build for, oops, keep doing that. Build for my BeagleBone Black, and it'll go through the same situation. It'll compile all of the code underneath the scenes for you, and go ahead and make a release and package that up nicely into a firmware image. Now, once we have that, we'll see under the images directory, we have both. Now, we don't really necessarily override one for the other. We'll allow you to be able to do both or all three. However many targets you have in your application, we'll cache that stuff for it so you can rapidly develop this for multiple platforms if you needed to. Okay, so right now we have this bare application that we can probably burn onto an SD card, but it's not really going to work because we're not really telling it to do anything, right? So this is really the smallest little piece of an application that we need to be able to get running. All right, from mix to burn, pretty much. Well, one other aspect of this that I want to talk about is a way that we can configure different targets. Well, because I want to blink for a Raspberry Pi, a way that I can get around that is by declaring additional configuration values. One, let's say, for each one of the targets. So let me just flip over to my slides here. All right. So here we have an example that shows how to be able to lay out configurations for each one of the targets. Now, why would we want to do this? Well, in the normal world for Elixir, all you're used to dealing with typically is environments, dev environments versus production environments. Well, in nerves, we need to deal with targets. You know, what thing are you targeting? What hardware are you targeting? What is it? Is it BeagleBone? Is it a Raspberry Pi? And if you need to be able to specify configurations that are different for each one of these targets, for example, like what the LEDs are called on the boards on the devices according to the Linux system, you can declare multiple config files that describe the configurations for those individual targets. So from here we can have we have a target for Raspberry Pi 2. And our main config, what we do is we go, okay, if there's a nerves target defined, let's import it. Otherwise, let's just skip over it for now and set some defaults. Right, so I'm going to switch over to this build for now that we've kind of created our basic one. These are examples that you can check out right from our website as well, or right from our GitHub page. And you can see here, this is where I'm at with these Raspberry Pi configs. So with Blinky, we needed an additional dependency, Nerves IO LED. And this is a framework that we provide that allows you to interface with the LEDs that are on board on a Nerves device. All we have to do is add this to our project dependencies, add it to our applications list, and then we can start configuring it for each one of the different boards. With that, we should be able to get a fully blinking device at this point. Yeah, it's amazing. So let's bake some firmware for Raspberry Pi 2. And what I'm going to do is I am going to take my SD card, part of the magic behind the scenes you can't see. I'm putting the SD card into my machine. Should be able to see it mounting here. And you can use bake burn. And what that does is it looks for SD cards on your machine. It asks you if you want to use the one that was mounted. You say yes. And it's going to require some elevated privileges. And once that's done, it's finished burning. So let's give this a try here. Let's switch back over to Hangouts. And now that we have that SD card burned, it automatically ejects it from our machine. I'm going to put it into my Raspberry Pi here. I've connected. All right. It's a Raspberry Pi 2. It's got a fancy case. It's kind of neat. Put this SD card in the Raspberry Pi. It's the one we just burned, and let's plug it in. So if I have the display connected, you'll see it'll take a little time to boot up. But then as soon as we're done booting up, we have some blinking lights. Yay, we just blinked some lights. Pretty exciting. All right, so that's usually the first place everybody starts, checking out Blinky. It's the hello world of hardware. Well, what more advanced things can we really do with this? So let's take a look. All right, we have another example project in our library called Hello Network. So, oops, sorry guys. So the first step is now you got some lights blinking. So let's take a look at how to get it onto the network and what cool things can we do then. This is also part of the Nerves example project, so you can check this out and build it on your machine locally. And a similar thing from start to finish. Really, all you can do is you pull this down. We can take a look at it and pick it apart. We'll see the mix file here. It's pretty much the same. We have Nerves as a dependency, and then we have Nerves IO Ethernet as a dependency, which gives us access to the Ethernet port on this device. So from here, we can call bake firmware after we've done after we have our systems, but we know that we already have them. Like I said, they're cached between projects. So we know we already have the system for the Raspberry Pi 2. We can just go right into being able to bake the firmware for the Hello Network example. And now we have our output of the Raspberry Pi 2 network firmware. So what I'm going to do now is I'm going to take my SD card, put it back in my computer for now, and we're going to try this out on a network-connected Nerves device. All right. The SD card auto ejects itself at the end of that, so all you have to do is then pull it out of your machine and put it into the Raspberry Pi, and you're ready to go. All right. So now back again here, got my setup. There's Chuck, Wi-Fi. Got my setup here with my Raspberry Pi. All right. And we're going to just connect this thing to the network now and power it up. So let's take a computer and face it towards a screen. And it's probably a little backwards, but everybody can see here now we're finally booted into the Nerves prompt. and we have some debug information about the local network that we have here. But ultimately, what we have is a network-connected NERVS device. And what we can do is some pretty cool stuff. We can load Phoenix onto it, but we can also go and create our own protocols if we want to. But one important thing is that now we have an ability to communicate with the NERVS node from across the network. One important thing to be able to say here is that when you boot up these devices, there's a couple different ways that you can use the Ethernet library to be able to connect this to the network. You can pass your own host names. You can use DHCP. You can use static IP addressing. But when it comes down to it, you want to be able to set the Elixir, the Erlang VM, so that it boots up in distributed mode, so you can do cool stuff like connect to it with remote shell. So that's one little trick that I wanted to show you guys today, was the remote shell portion of this. And how you can sort of check out what's happening on your NERVS node from your host computer. So we'll do a little bit more live coding here. Woo, fun windows, yay. All right. So you can't see it, but my screen, when it boots up, it's going to say what the node name is at the bottom. And the node name usually consists of NERVS dash, and then on the Raspberry Pi, we pull the Raspberry Pi serial number and we grab the last 4 characters off the end of it and make that the host name that we set for the device. So when it shows up in your network, you can communicate with it like that. So my host name on mine is NERVS-9063. I know that because I'm looking at the display here. So with that host name registered, I can use that to be able to connect to it as a remote shell. To do that, we can use IEX's rev shell function. And what that looks like is this. Let's just do IEX. We're going to set a short name. I'm going to set this to a debug or something. We have to make sure the cookie's the same. And the cookie in this project, you'll find the VM args we checked in. I believe we set it to demo cookie. So we're just going to set our cookie to demo cookie. And then what we need to do is we need to pass it the shell that we want to connect to. We're going to say hello network app at NERVS 9063. And if everything goes right, which it did, hooray, we are now connected to that node. So I can show you a little bit of what's on here just to say, you can see what working directory we're in. You know, our Elixir applications we usually put under /srv forward Erlang. Then under that is where our Elixir application exists. We can even look at what's on the root directory of this drive, so we can see that this is what's included typically in the root of this. You can see that it's a very light operating system. There's not a lot in here. But we can do some neat stuff now. We have the ability of connecting to the remote node over the network. We can pretty much use this as a debugging practice. Now this brings me into an idea of the NERVS development cycle. Some of us, what we do is we, while developing stuff for NERVS, NERVS is really, like I said, a really small footprint, powerful way to be able to distribute embedded Elixir applications. So when developing, you can really install like Raspbian or Debian if you wanted to be able to just try to get started. If you wanted to be able to just like SSH into the machine and just live on the shell, you could. This is another way to do it, but since it's read-only, you can't really make file changes without redeploying the SD card. Now we're working on Cell, which is one of our tools that's going to allow you to be able to do remote firmware updates. It's really going to enhance the development cycle and make things pretty rapid. In the meantime, we suggest that if you wanted to be able to play a little bit more in depth with interacting with some I/O on the device, let's say, like you couldn't get on your desktop environment. Yeah, put a version of Linux on it, and after a short period of time, you'll understand the kind of pain that it takes of compiling Elixir in Erlang and how long it takes to be able to get that up and running on a smaller device, on a smaller processor. All right, so those are some of our example projects. You can go check those out and start to play with them. And there's a few other things that I wanted to touch on. So one of which is how we use nerves in production. Well, like I said, this is really what it's geared towards. And there's several ways that we do this. One way is that Garth Hitchens, he is one of the core team members of Nerves, contributes a lot and his team towards the forward progress of the frameworks and the systems. His company, Rose Point Navigation, they shipped these 2 devices so far to be able to interface with all kinds of, in one case here, they have a commercial radar interface, which basically interfaces a protocol that's for the marine use to that's very very sort of low level to something that's a little bit more digestible, like JSON or an Ethernet interface that they can use to be able to mash up with other data. You can check out more about these guys on their website. Go look up Rose Point Navigation. We're also working on creating some additional projects and examples for working to be able to put out there for you guys, like deploying Phoenix applications. We're also working with Chris to be able to create an example where you can do Phoenix presence. It's really going to show that off coming up. We're also doing an install at a local distillery to be able to automate their still using an installed Phoenix application and controlling actuated valves, things like that. And there's also a number of community projects that are out there. There's a lot of action on Twitter. You can follow us and get updates about some projects that people are working on. I know Wendy is part of a channel. She's working on automated cat feeder. There's somebody working on some brewing equipment, I believe. There's also talk about security systems, and everybody's got all kinds of great projects. It's really cool. And so I beg you guys that if you have any additional questions or you want more information about this, you can check out Garth Hitchens. He's going to be at Elixir Days tomorrow, which is happening in Florida. He's going to be talking about similar concepts, getting started, the road ahead for Nerves, things that we're going to be working on towards for 2016. And you can also find us and learn more at our website, nervesproject.org. There's the GitHub repository where you can download a lot of the examples. You can also get some more documentation on how to be able to deploy some of these images. And if you have any other questions, you can always find us on the Slack channel at Nerves on the Elixirlang Slack. And I hope that you guys enjoyed it. I hope that you have questions. I hope that it makes you really want to get out there and work on creating some new fun experiences using Nerves. I beg you, if you have any problems, if you get stuck, come and talk to us. We're usually always able to work things out, get some help there with working with I/O and things like that. So thanks for attending. I'm sorry that we didn't have a few extra cameras. We're hoping to be able to make this a little bit more robust, but maybe we'll try some different platforms for next time, and we'll see you soon. Thanks. Oh, and catch us afterwards on the Elixir channel if you had additional questions.